Dear student, in this video we will learn chapter number 2, real numbers, practice set 2.1. If you have not subscribed my channel, please subscribe it today itself. Let's start. What are rational number? The number of the form m upon n are called rational numbers. Here m and n are integers, but n is not a zero. So what is a rational number? It is a fraction. It is in the form of m upon n, where numerator and denominator of this fractions are integers, but denominator should not be 0. Let's see some examples over here. Here we have the first example, minus 25 upon 3. It is a fraction. You can see here the numerator is minus 25, which is negative integer, and denominator is 3. It is positive integer. So here we have a fraction whose numerator and denominators are integers, and you can see that here denominator is not a 0. Therefore minus 25 upon 3 is example of rational number. Similarly 32 upon 3, it is also fraction, and you can see the numerator of this fraction is 32, which is positive integer, and denominator of this fraction is 3, which is positive integer. It means numerator and denominator of this fractions are integers and denominator is not a 0. Hence 32 upon 3 is example of rational number. 10 upon minus 7 is also a rational number. Minus 4 is also rational number. Just now I said that rational number is a fraction. Okay, you can see minus 4 is not a fraction, but minus 4 can be written as minus 4 upon 1. If I write minus 4 as minus 4 upon 1, the meaning of the number will not change, the value of the number will not change. Okay, now you can see it is a fraction, and here the numerator of this fraction is minus 4, which is integer, and denominator of this fraction is 1, which is also integers. That means numerator and denominator of these fractions are integer and denominator is not a 0. Hence minus 4 is example of rational number. Similarly 0 is also a rational number. What is decimal form of rational number? Decimal form of any rational number is either terminating or non-terminating recurring type. Okay, the decimal representation of any rational number can be terminating or non-terminating recurring type. Let's see some examples over here. Okay, first we will see the example of terminating type. Okay, you can see here we have a rational number 2 upon 5, right? It is a rational number, and when you will divide 2 by 5, you will get 0.4. okay, so in this case here the remainder is 0. Okay, you can see here the division gets over, so 0.4 is terminating type of decimal representation. Similarly minus 7 upon 64 is equals to minus 0.109375. It is also terminating type of rational number. Now we will see non-terminating recurring type. Here we have example 17 upon 36. If we divide 17 by 36, you will get 0.47222222. okay, the division is endless, so it is non-terminating, never ending division, so non-terminating. And you can see that here the digit 2 repeats again and again, right? You can see here the digit 2 repeats again. That's why it is recurring type. Okay, here digit 2 repeats again and again. So 0.47222 can also be written as 0.47.2. You can see at the top of 2 there is a dot. The dot shows that 2 is digit which repeats again and again in the decimal form. So this kind of decimal form is known as non-terminating recurring type. Okay. Here we have the another example, 33 upon 26. If we'll divide 33 by 26, you will get 1.269230769230 dot. That means it is non-terminating, never-ending division. But here you can see that 692307, right? 692307. Okay, you can see that 692307. This group of digit is repeating again and again. Okay, it's recurring. Therefore, here 1.2, and you can see on the top of group of the digit that is 692307, there is a bar, there is a horizontal line. The horizontal line shows that this group of digit repeats again and again. So it is non-terminating recurring type. So the decimal form of rational number can be terminating type or non-terminating recurring type. Make a note, make an important note over here. If the prime factors of a denominators are 2 or 5, only then its decimal expansion is terminating. Okay, when the decimal form of a rational number is terminating, when the prime factors of denominators will be 2 and 5, 2 or 5, then the decimal expansion is terminating. But if the prime factors of denominators are other than 2 or 5, if the prime factors of the denominators are other than 2 or 5, then the decimal form of that rational number will be non-terminating and recurring. Now we will see some examples over here of each one. First we will see terminating type. Okay, you can see 4 upon 5. What is denominator over here of this fraction? It is 5. And just now I said that if the prime factor of a denominator are 2 or 5, then when the decimal expansion is terminating, and you can see here the denominator is 5. If the denominator is 5, if the prime factor of denominator is 5, then you can see the decimal form of this number is 0.8, which is terminating type. So how I came to know that the decimal form of this fraction is terminating? With the help of the prime factor of denominator. Alright, if the prime factor of a denominators will be 2 or 5, then only the decimal expansion will be terminating. Let's see other example over here. Minus 7 upon 64, right? What is the denominator over here? It's 64. And what is the factor of 64? 2 into 2 into 2 into 2 into 2 into 2. That will get 6 times 2. And you can see the prime factors of this denominator is 2, right? Only 2's. So the decimal form of this fraction will be minus 0.109375, and you can see that it's terminating decimal form. Okay, so if the prime factors of denominators will be 2 or 5, then definitely the decimal expansion of that particular rational number will be terminating. Now we will see some examples of non-terminating recurring type. Okay, here we have first fraction 7 upon 9, and you can see here the denominator of this fraction is 9, and the prime factor of 9 is 3 into 3. Okay, and we know that if the prime factor of a denominator is other than 2 or 5, then the decimal form of that rational number will be non-terminating and recurring. You can see the example over here. You can see the decimal form of this number 0.7777, right? So it's a non-terminating and a recurring, which you can write as 0.7. Now we have the second question over here, second example over here. Let's see the second example over here. It's 33 upon 26, and what is denominator over here? It's 26, and the prime factor of 26 is 2 into 13, right? 2 into 13, and you can see the one of the prime factor of this number is other than 2 and 5, right? Yes or no? So the decimal form of this rational number will be non-terminating and recurring. You can see here it's 1.2692307692307 dot dot dot. So here the group of digit is repeating, that is 692307, and it's a never ending division, so it is non-terminating recurring type. So make a note, if the prime factors of denominators are only 2s or 5, then only the decimal expansion will be terminating, and if the prime factors of the denominator are other than 2 and 5, then the decimal form would be non-terminating and recurring. Let's see, here we have the question, classify the decimal form of the given rational number into terminating and non-terminating recurring type. Okay, we have to classify the decimal form of the given rational number into terminating and non-terminating recurring type. Okay, here we have first question, 13 upon 5. What is denominator of this fraction? It's 5, right? And we know if the prime factors of denominator of a fraction is 2 or 5, then the decimal form will be terminating. So your denominator of the fraction is 5 and 5 is prime number. Okay, so the decimal form of this number, okay, what is denominator of this number? 5, and denominator has only 5 as a prime factor, therefore minus 13, therefore 13 upon 5 has terminating decimal representation. Now we have the second question over here, 2 upon 11. What is denominator here? 11. And what is a prime factor of denominator? 11. That is 11 only. And we know if the prime factor of a denominator is other than 2 or 5, then the decimal form of that particular number will be non-terminating and recurring type. So let's see the solution here. In 2 upon 11, 11 is denominator, thus denominator has prime factor other than 2 and 5. Okay, denominator has prime factor other than 2 and 5, that is 11. Therefore 2 upon 11 has the recurring and non-terminating decimal representation. Here we have the question number 3, 29 upon 16. In 29 upon 16, denominator is 16, and the prime factor of 16 is 2 into 2 into 2 into 2, right? Thus denominator has only 2's as a prime factor. You can see the prime factor of the denominator is only 2. Therefore 29 upon 16 has terminating decimal representation. Fourth one, 17 upon 125. In 17 upon 125, 125 is the denominator. And what is the prime factor of 125? 5 into 5 into 5. And you can see here the prime factor of the denominator is only 5, right? Denominator has only 5 as a prime factor. Therefore 17 upon 125 has terminating decimal representation. Here we have the next question, 11 upon 6, and here the denominator of this fraction is 6. 6 is the denominator, and the prime factor of 6 is 2 into 3. 2 into 3 is 6. So the denominator has prime factor other than 2 and 5. Okay, other than 2 and 5, that is 3. Therefore 11 upon 6 has recurring and non-terminating decimal representation. Okay, because this denominator has prime factor other than 2 and 5, that is 3. Here we have question number 2. Write the following rational numbers in decimal form. Here we have the first question, 127 upon 200. Okay, let's see the solution of this question. Now what we will do, we will divide numerator and denominator of this fraction by 2. Why we are dividing numerator and denominator of this fraction by 2? To convert the denominator in tens or hundreds or thousands. Okay, so I am dividing numerator and denominator of this fraction by 2. If I divide 127 by 2, I will get 63.5, and when we will divide 200 by 2, we will get 100. 63.5 upon 100. Now it's easy to convert this fraction in decimal form. Okay, you can see the denominator of this fraction is 100, right? There are 2 zeros, okay, in this denominator. So this decimal will move towards left side of decimal, right? It will move 2 steps left side of this. So decimal will come over here. Okay, so what you will get? 0.635. That is a decimal form of this given fraction. So therefore 127 upon 200 is equals to 0.635. Here we have question number 2. 25 upon 99. It's not easy to convert 99 into tens, hundreds or thousands. So in this case we will divide 25 directly by 99. 99 zeros is 0. So 25 minus 0 will be 25. Now there is no digit in the dividend, right? You can see here there is no digit to copy, right? Yes or no? So what we will do, we will put decimal. Okay, we will put decimal in the numerator. Okay, so we can take 1 0 beside 25, it's 250. Now 99 twos is 198, and 250 minus 198 is 52. Okay, now we can take 0 beside 52 because already we have taken decimal in the quotient. So it is 520. 99 fives is 495, and 520 minus 495 is 25. And you can see that now here the remainder is 25. Okay, here remainder is 25. Already we have divided 25 by 99 and we got here 0.25. So if I'll divide 25 again by 99, I will get the same thing. I will get again 25 here. Okay, so we will get here 0.25252525, right? It means the decimal form of this fraction is non-terminating and recurring. So 25 upon 99 will be 0.25. 23 upon 7. You can see the denominator is 7 and it's not easy to convert 7 in tens or hundreds or thousands. So here straight away we will divide 23 by 7, and if we will divide 23 by 7, okay, the division never ends over here, and you can see here it will keep on going, division will keep on going. You can see here we got 2, okay, and already we have divided 2 before. Okay, before we have divided 2, you can see here 2 I have divided by 7. So if I'll divide this 2 again by 7, so what we will get here, we will get here 285714 again. Okay, so the decimal form of 23 upon 7 is 3.285714. 285714 is the group of digit which repeats again and again. Now here we have the next question, 4 upon 5. Now it's easy to convert 5 in tens or hundreds or thousands. So we will multiply here numerator and denominator of this fraction by 2. So what will get here, 4 into 2 upon 5 into 2, that is 8 upon 10. Now it's easy to convert 8 upon 10 in decimal form. Okay, when we will divide by 10, okay, we will get here 0.8. Therefore 4 upon 5 equals to 0.8. So make a note, if it's not easy to convert denominator in tens or thousands or hundreds, in that case you have to divide directly. Okay, let's see here the next one, fifth. 17 upon 8, right? And you can see that 10 or 100 or 1000 doesn't come in table of 8. So we will divide directly 17 by 8. 8 to the 16, right? 17 minus 16 is 1. Now there is no digit to copy. So what we will do, we will put decimal in the quotient and we will take here 0. 8 ones are 8. Okay, now we will subtract 8 from 10. We will get 2. Now we will take 0 beside 2. Okay, so 8 twos are is 16. 20 minus 16 is 4. Now we will take 0 beside 4. And 8 fives are is 40. So your remainder is 0. So the decimal form of 17 upon 8 is 2.125. Write the following rational number in P upon Q form. 0.6, it means it is 0.666666. It's a non-terminating recurring decimal form, so it is rational number, and this rational number we have to convert in fraction in the form of P upon Q. Let's see how to convert 0.6 in the form of P upon Q. Let x equals to 0.6. okay, I have considered that this number is equals to x, and that is equation number 1. Now look at over here, how many digit is repeating here again and again. One single digit, 6. Okay, single digit 6 is repeating again and again. So what we will do, we required 1 0. Okay, that means we will multiply by 10. Why 10? Because there's only one digit is repeating, 6. If 2 digit will repeat again and again, then we will multiply by 100. If 3 digit repeats, then we will multiply by 1000. So here I am going to multiply both the side of equation 1 by 10. So what we'll get here, x into 10 is 10x, and 0.6 if we'll multiply this number by 10. Okay, so what will happen, one of the 6, there are many 6 after decimal, one of the 6 will move towards left side of decimal form. Okay, here, so you will get 6.6. Now we will subtract equation 1 from 2. Okay, we will subtract equation 1 from 2, that is 10x minus x equals to 6.6 minus 0.6. So 10x minus x is 9x, and 6.6 minus 0.6 will be 6, right? So x equals to 6 upon 9. Okay, it is a fraction, we will write in simplest form, that is 2 upon 3. So 0.6 can be written as 2 upon 3. Now here we have the next question, 0.37. okay, it means it is 0.37373737 dot. That means here the group of digit is repeating, and again there is 2 digit in this group, that is 37, right? So 37, 2 digits, so we require 2 zeros, so we will multiply by 100. Okay, so x into 100 will be 100x, and 0.37 if we'll multiply by 100, so what will happen here, there are many 37s, okay, to the side, 37, 37, 37. So what will happen, one of the group 37 will move towards left hand side of 0, so we'll get 37.37. Now we will subtract 1 from 2, so 100x minus x equals to 37.37 minus 0.37. So 99x equals to 37, so x equals to 37 upon 99. Therefore 0.37 equals to 33 upon 99. Here we have the next question, fifth one, 2.514. okay, that means it is 2.514514 514 514 dot. Okay, so I have considered this number as x. That is equation number 1. How many digit is repeating over here? 3 digit is repeating. 514, right? So we will multiply by 1000 because 1000 has 3 zeros. And here 3 digit is repeating. So we'll multiply by 1000. So multiplying both the side of this equation by 1000. So we will get here 1000x equals to 2.14.514. Okay, if we'll multiply by 1000, what will happen? Thus, there is a many groups of 5 upon 514. So one of the group will move left side of decimal here. Okay, you can see here. Okay, now we will subtract 1 from 2. So 1000x minus x equals to 2514 point bar 514 minus 2.514 bar. So you'll get here 999x equals to 2512. Okay, so x equals to 2512 upon 999. Okay, therefore 2 point bar 514 can be written as 2512 upon 999.